The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. DuPont, Hawaii Tracker, and H. Berry, the Hawaiian Volcano Education and Resilience Institute. How are you today, Dane?
Oh, doing good, doing good. How about yourself?
Doing all right. And if you guys are watching us on Facebook or YouTube, you'll notice up in the upper left corner of our screen today, we have a new thing going on. What's happening with that, Dane?
Yeah, we have two new people joining us, Carrie and Dano. They are sign language interpreters. They've been helping out, with the county events when possible. We met them down in Pahala and before the Mauna Loa eruption, so we're glad to have them on board now. They're really going to try and help us out a little bit, give some sign language interpretation for the stream today.
Yeah, awesome. So today is Thursday, August 31st, 2023. This is the Hawaiian Volcano Tracker, bringing you guys an update on both Kilauea and Mauna Loa volcanoes here on Hawaii Island. And as usual, we'll recap the activity on both. The earthquakes happening on the volcanoes have been the story of the past month, and so we'll talk about that a little bit. And otherwise, we'll just catch up with where we are today. Anything to add before we jump into it?
Yeah, if anybody may have noticed, Phil's have a little bit of lag today. We're going to try and make this work. Hopefully, we're going through patches where it's good for a bit and it's bad for a bit, and there's nothing on Phil's end. Lou is having the same issues. Yeah, so we're going to try and make this work today. And I appreciate you bearing with us a little bit. Also,
right.
we will be active in the chat. If anybody wants to drop anything in there, we'll be trying to interact with you guys.
All right, so let's try this out here with a little bit of lag perhaps, but let's get things lined up for us here and see how we look here. And here is this week's Hawaiian Volcano summary. On screen here, you can see the earthquake pattern on Kilauea.
We might have lost Phil as soon as he started going into that there.
I heard a little drop right there, so I paused and try that again. Huh?
Yeah, it cut out as soon as you went going.
So let's try again. Cross finger system. Hawaiian Volcano summary this week. You can see the earthquake pattern on Kilauea. Most of the activity is focused southwest of the summit caldera this past week. Unlike the previous week, where it was more so around the caldera itself. We still have a good amount of earthquakes here within the caldera region. It seems activity has shifted over the last week from inflation and more so on the caldera center to a little bit further south here, an area that's often known as the seismic southwest rift that we call the southwest rift connector. So that's the pattern of earthquakes in space. And here are the rates over the past month. So this is the last 30 days of earthquakes per day of data. So we are right here on the right end. And over the past week, our highest value was close to 250 earthquakes. And that's across the entire Kilauea summit and Pahala area and South Link as well. And so the earthquake peaks came down, and we had about 175 earthquakes per day for most early part of the week here, until over the last days, it's stepping down just slightly, mildly so. But even the most recent values are still elevated as far as earthquake rates compared to what we had happening 1 month ago, which was prior to this first flurry of activity that's in that southwest rift connector. Here we have that second the second surge of activity. And it seems like quakes are going off, and that's coincident with the swelling shifting to the south. You can see this most clearly on the sand hill tiltmeter, which typically plots two different components. There's a blue line and a green line on here. This blue line is the direction to Halemaʻumaʻu. And what you can see is that it has been increasing, but it's a little bit flatter here over the last week. However, the green line, which is what we call the tangent component, the tangent 90 degrees from Halemaʻumaʻu points toward the south there, this component has actually been increasing pretty steadily. In fact, the absolute amount of tilting from that direction is pretty notable, and it suggests that magma is filling that the southwest rift connector in that area near the caldera there. So that's the story on Kilauea. We'll wait to see whether that continues to be the pattern. We've seen similar patterns to this prior to eruption in December 2020 and September 2021. So you might project that this is part of the buildup sequence to what happened in the past was eruptions at Halemaʻumaʻu. So that is still what we expect, something in a not distant future, but actual mechanics of how we get from there is still something that has to play out. We'll have to wait and see what actually happens. There are very few earthquakes. The volcano is still inflating and swelling. And what's interesting to us over the past couple months now has been these deep earthquakes on this plot are shown as the purple and blue dots. Here they are underneath a area a little bit to the southwest of the summit. And these earthquakes have slowed down. This is the last week of earthquakes on Mauna Loa, and you can see only a few here in this area. So still happening sporadically, slowing down. Otherwise, the volcano is behaving as expected, refilling magma following its 2022 eruption. And that's our Hawaiian volcano summary for this week.
Well, you got through it. I hope everybody was able to hear that, and Dana was able to get that interpretation out. We'll try and, I'll try and hop in and help whenever possible. But yeah, this is probably going to be what we're dealing with today. I just want to apologize for everybody and try and leave it there so people are aware.
All right, so I'll keep going as well as I can here. And the visual for you guys. Our Kilauea observations have been fairly limited on the surface. Lots to see, but not a lot changing volcanically. Here is an image from the KW webcam earlier today. Nice rainbow shown over Kilauea, reflecting the weather has been variable here over the last couple of days. Sun and rain both. Currently, it's pouring out in my window. So there's Kilauea, still quiet on the surface. Observer-wise, it is still putting out gas, and so we'll shift to show volcanic hazards. And we, as usual, rely on the Measurement and Prediction Project at the University of Hawaii in Mauna Loa. And their forecast this week includes not very much gas coming from Kilauea, only 7 tons per day being emitted, which for the volcano is a low value. And given the weather conditions, it's dispersed according to this distribution here on the screen. So not intense anywhere that we can see the next couple of days. Usually it shows up in yellows and oranges and sometimes red, one very intense. So overall, fairly clean air. Although even these low levels of volcanic emissions can be impactful for people in nearby caves, especially the volcano, Paha, Lehu, South Point, those areas that are getting persistent chronic fog at those areas, and people can have stabilities. So that is, as usual, though, major history there as well. And correspondingly, we can see that the Purple Air Citizen Science Monitoring Network of monitors of those houses to this website is showing mostly greens all the way around here. We have a couple of anomalies that usually pop here that are not to do with the volcano. So that is the volcanic hazard summary here. And with that, we will move on to our Kilauea monitoring. So let me pull that up on the screen here for you guys and find our graphs, which here they are. Starting off last week of earthquakes, you can see here earthquakes per day over the last week. It's something that I thought would start off by pointing out hazards of some of these plots. It looks on the left side of the graph here that back on 24th there are not many earthquakes, but what you have to realize is these things are automatically generated, and there's a certain cutoff that it has, so it's only counted that way, and it makes it look like there's less earthquakes. It usually happens both at the left end and the right end of the graph here. These are the sus parts of the graph. The middle part, we can see the earthquakes were fairly steady, 150 earthquakes per day for the first couple of days of the week, bumped up above 200, and then came back down, and since then have been down slightly and gradually. Where the most recent value is still over 100 earthquakes per day. So low earlier in the week, but still high in absolute terms. Over that same week, we can get the depth versus time over here and confirm that most of the earthquakes are the ones plotted here in the orange band in a shallow region of Kilauea's magma system here. That's the part that's all active up here in the upper band. And sometimes that's not the case. Sometimes it's lower band of these dark blues, which is often the earthquakes in Pahala cluster in the direction of Kilauea. Sometimes that is more active, and you can have anomalous peaks on your graph because of earthquakes at different depths. So just to confirm, we're looking at the earthquakes that are all in a magma system here in this upper part of the graph here. Over the last month, earthquakes per day once again. We're just looking at that bump right over here. And so you can see that that day, the 24th, did not have as few as 50 earthquakes as it might have appeared in that graph. It was still well over 100. Here you have a full range over the last week and a half, so coming up and coming back down. Now, it's very interesting to compare the same month timeline that we have, and we've been looking at against the summit tilt, and here it is. And so the tilt has interesting signals. We could generalize that it's been coming up at a fairly steep graph tilt rate, more or less until last week, something like that. You do see this anomaly, almost like an inflation-deflation event superimposed upon it here. It occurred a couple of weeks ago. But that overall pattern is still fairly unchanged, even coming out of it, where it seems to be heading up, until right around the 23rd, 24th or so, right around 1 week ago. From that point to now, you do see these deflation, inflation fluctuations along it, but the overall pattern has been a very little net gain here. So you can see that the ground tilt coming from the Halemaʻumaʻu region, and this blue line is the Waikahuna station, is showing that flattening of the ground out here over the last week right there. And that's the same pattern we see as we earlier on Sand Hill meter. This blue line right there, that's the one pointing towards Halemaʻumaʻu, that flatter spot. And in stark contrast, let's zoom in, it's really obvious for everybody here. In stark contrast, you see this green line rising pretty rapidly here. So we'll look at this on a map here in just a minute, but just I'll finish going through the signals first. Looking at the east zone over that same month of time, you can see the opposite pattern. The direction of the rift zone is blue line going down with a couple of little deviations for earthquake there and rain and air, but overall the pattern is contraction. The ground is sagging as it's losing pressure within the rift zone down there. Right? It's not pressurizing with magma, unlike the summit. So the ground is kind of swelling and settling as the south flank moves, and the whole thing adjusts and wiggles in there. So important that even though we see that center of inflation moving a little bit, it's not moving farther down the rift zone, and it's moving towards where people are. So there's no extra cause for concern for communities at this point in time. Zooming out to the last year, we'll look at the SO2. The most recent value of sulfur dioxide gas coming up from the summit was 75 tons per day. This value way down here, that's as we referred to in our hazard forecast from the VMAP. So that's fairly low. You can see that during eruptions, these values can get to tens of thousands, almost hundreds of thousands, depending on eruption. So far so good until the next eruption pops up. Then we'll get it to get bad for a few days and then gradually get better over time. Still sticking to the last year, here are earthquakes over that period of time. Now we're looking at earthquakes per week. So this right here is 1,000 earthquakes per week. And what you can see is that over the last year, we've actually now hit that threshold. 1,000 earthquakes in the past week is the highest week earthquake count over the whole last year. You can see that we've exceeded the earthquakes that preceded the June eruption in here, and we've outpaced the ones that preceded the January eruption as well. So it seems like the volcano is somehow strengthening in some way, where each eruption is taking higher levels of earthquakes, more intent, a greater accumulation of earthquakes to actually break through its eruption to this. So that's the last year of earthquakes there, and just progression here. And you can see that in the last two sequences, the earthquakes ramped up to these higher levels, not just for 1 week, but for several weeks in a row. And so that's what we would expect here, is perhaps it could be sooner, but potentially every week still of earthquakes in the area to the pattern of the previous eruptions matching up there. But what's different here, if we look at the GPS for the last year, at least temporarily here, this is a distance from north to south across the caldera. And so when this line goes up, the distance is getting larger, the sides are moving apart, the volcano is swelling, bulging outwards. So over the whole last year, you see it kind of swelling, and once in a while it dips down, it contracts a little bit. It usually corresponds to rains. This was a January eruption right here. Following that eruption, it stayed contracting for a while before it picked back up, resumed swelling, sometimes faster, sometimes slower, sometimes faster, until it erupted once again in June. And that's what this little offset is. Stretched out really far to cause lava to come out, then sagged as it did. Once eruption was over, it resumed its swelling once again. Well, now you can see at this far right side of the graph here where we are, that we've had a little bit of sagging and expansion, and now we seem to be a little bit leveling off there, which is interesting, because this would suggest that within the boundaries of the two stations, one to the north of the caldera and one to the south, that area between has not actually been expanding. But as we've seen in the tiltmeter, it could be expanding outside that area, just to the south of there. So that may be what's going on here. In any case, it is showing that shift in inflation center once again. And finally, looking at the GPS here for the last year at Pole in the East Rift Zone, the pattern is still that of contraction. The sides are getting closer together. That thing is sagging, which is the same pattern supported by the tiltmeter we saw earlier. So all is good there. Before we jump into a little bit more of the maps, I just thought I'd point this out in the earthquake pattern once again. Here's a last month of earthquakes, all of them, not just last week. And you see over that time, zoom in there, you have not only this West Rift Zone extension right here, but quite a lot of population of these dots right across the caldera itself, where it's hard to even see the shape of it on the map. Compare that to last week. Put it on screen here. Certainly there are earthquakes in the Kilauea region, but not so many that you can not see the shape of it anymore. And most of them are actually concentrating down here in this area to the south. It's got a little bit of a wiggle in it right there. We'll dive into this a little bit more here as we get into the story of the earthquakes. But to finish off our story, I thought what I would do is take us to Google Earth here. So hopefully this will work for us. And I'll show you here an image of the caldera area. There are two shapes that are colored on here. This one up here is a 1982 flow from September 82, did within the caldera somewhere here more or less, and flowed with that post. And there's also down here this reddish color. This is a 1974 eruption that came out of December 74, came out of that southwest area as well. Just showing possible eruptions that we talked about last week a little bit to the extent. And what I want to do is put out, this is our tiltmeter at Sand Hill right here. And let me zoom it in and make the image bigger. So I'm going to click it and show you guys. But this is the one that shows that the green line going up and the blue line staying fairly steady. So the center of the station is right around in here. Let me zoom in a little bit more too. So the blue line is pointing basically at 45 degrees northeast, like that, to Halemaʻumaʻu, that. And then the green line is the one pointing 90 degrees off of that over here, like that. So this is the area of suspicion right in here, east of the Sand Hill area. If we're considering the distance between the crater rim and Wikahuna, the GPS, that distance across caldera north to south is more or less something like that. So it can actually exclude this area to the south. And further, if we go over to the Ahua station, which is this GPS station over here on the just southeast of it, it's hard to see this so clearly here. So let me come back to our maps and do it up here for you guys. The Ahua plot. And it's got three components here. This one's the east-west component. This is the north-south and the up-down. So we can see this got its patterns. And these are now two plots, so the thing is extra compressed. But what can we gather from here? It's interesting from the. It's hard to tell conclusively because the data is so recent on this graph. But you see how this line of blue dots was headed downwards. And it seemed like it was going to crash into this little black tick mark right in here. And that's right next to this line right there. Instead, it seemed like the last several data points, most of this last week, I would wager, seems to have flattened out right there. So what this means is this component, the north-south component, Ahua, which is just south of the summit, was moving to the south, and now it's not moving north or south much at all. So back to our map here on Google Earth, that's the station right here. It was getting pushed to the south, and now not much at all. So not much at all would mean that something has come to the range of how far south it is. This is how far south it is right in here. So once again, we have indicator for the station, not quite as clean as the meter right here.
We hit a spike there. We're talking about the tilt meter, or it's the GPS, just before the transition is where you cut out there. Just wanted to give you a second to maybe see if the internet comes back together, but wondering about your thoughts on that. We've talked about this before, the GPS, those ones right along the edge, those latest data points and how they might be adjusted and kind of portray something. So what are your thoughts on that? Let's see if you're back.
Yeah, you certainly need to be careful with those most recent data there in the GPS. It is consistent here that the GPS station is showing that pattern as well that we see, and so that's one of the things that we use for verification or strength of a data set. Multiple stations pointing at the same conclusion, and even with the data being pretty recent, and we would like to wait to have better data from there, it does look consistent with what we're seeing from the tiltmeter there. And both the tiltmeter over to the northwest and this GPS station in the southeast are both pointing to this area in between them. And so that's the suspicion right there. And won't go into the detail of all the inflation sequences we did last week, but this is the same that we inflate prior to December 2020 and September 2021. So no big surprise there. So that's interesting to see it do that. It seemed like it was doing it with more earthquake swarms, that is, many events happening in a short time and area. And it seems like it's gone from that to it's downshifted somewhat, where not swarming as much, there's still elevated activity, but it's not coming in these big clusters of events in big bunches. And that's something that's reflected in the USGS update. So just wanted to put out here Google Earth how this distribution actually fits, and once again, the pattern of it not reaching the East Rift zone all over here, that tiltmeter still doing deflation. And the Middle East Rift, well, this is the Middle East Rift here, and this Upper East Rift connector here showing a little bit more intermediate signals, but in any case, no earthquakes in the Upper Rift connector, which had previous sequences, like we said last week, prior to 2020 and 2021, and now focused only in the southwest, and with some effect as well. So let's come back to our plots here. And what I'll do now is complete monitoring, touch base with the USGS, and I'll go back to an update from earlier last week, actually. This goes back to before last week's update, Tuesday the 22nd. You're putting it there now, but just note how early the USGS was on this. Okay, nothing out here. So let's pause for a minute.
Yeah.
Am I back?
You're kind of back. Your download is a lot better than your upload, let's just say, but it's a constant state of auto tune is kind of where you're at right now, but it mostly is decipherable.
Right. So I was going to go through the updates, selected ones here, starting with one a week and a half ago, actually, just to point out how early the USGS was on a pattern of the sample meter. They note there on the 22nd Tuesday last week that even though the Oahu tiltmeter recorded a small deflationary tilt trend, the Sand Hill tiltmeter southwest of the summit continued to indicate inflation. So that was the pattern even from before the switchover last week. We'll jump ahead now to Monday of this week. Recapping that earlier part of the week, they note that elevated activity, seismicity, continues in the area south of the caldera. It occurred steadily through the day yesterday without swarm activity. Otherwise, the details here are unchanged. I won't read through them, but we'll step forward to Tuesday when they note levels were slightly lower yesterday than the previous day. So they're noting that same decrease in seismicity. And stepping forward one more time to today's update, note that it's activity, continuing area south of Caldera. Steady rates of earthquakes have persisted in this area since August 22nd, with notable swarms the past day and really the past several days there. Otherwise, it's unchanged. There hasn't been anything noteworthy that's different in these updates, but they are still saying the same thing. And this is our primary data source, and so we'd like to make sure that we source information and give credit to here.
Phil, maybe try turning off your webcam and see if that helps. It's really all we need is the voice.
Yeah, let's just try to keep going, huh?
Yeah, let's just try and keep going.
Okay, so turn now to a little bit more information on the earthquakes. Here's a USGS map of earthquakes the last 7 days. You can see here that these are the events of large enough magnitude to plot on the web version. The map we just showed you guys earlier with the USGS generated colors for depths, those included a lot smaller events that don't show up on this map. So the events here are clearly showing on that south part of the caldera. They actually show a little bit of a bend to the southwest here and a little bit south as well. So it's a little bit of a wiggle. It does a shape here. And this is a pattern described previously in the scientific literature of Kilauea. This is exactly the pattern of the seismic southwest here. The earthquakes in that area are usually fairly shallow. And they seem to go south from the caldera region until they intersect this series of faults called the Kilauea fault system right through here. And that's where they seem to take deflection over and down. And so to show you this in a little bit better detail, I have this image from a paper by Donson about the Kilauea fault system. And this is black and white, so not prettiest perhaps, but I'll zoom in here. Showing you guys the edge of the caldera is up here. Outermost caldera faults are marked right there. I'll highlight for you guys there. And here, cutting across it is the seismic southwest rift zone, SSRZ, which they propose is better termed the southwest rift connector. So if you've ever heard where I get this term that I keep repeating, southwest rift connector, it comes from Dr. Don Swanson. In this paper from 2018, diets in the Kilauea fault system. So you see that there, actually south hits these black lines here, fault zones at the surface, hits the fault system, then deflects to the west, and that's where it gets to other parts of the southwest rift, where it could potentially erupt anywhere in that whole range further off to the southwest. And why does it have a funny shape? This is an interesting parallel to the east rift zone. So this is an image from that same paper showing the other side of Kilauea, the eastern side, Halemaʻumaʻu, indicated here as the Magma reservoir. And this is showing 3 stages of time. It's showing time early in volcano's life, time number 1, where the East Rift Zone connector, ERC, was aligned with the East Rift Zone as the volcano was growing out from the ocean and not really pushing against Mauna Loa quite so much. Because what happens when it grows is that this rift zone wants to expand, and it wants to expand in both directions, north and south. Unfortunately, to the north is the giant Mauna Loa, so any push this volcano rift zone has to the north ends up not moving Mauna Loa, but it moves itself further to the south. So the rift zone itself keeps migrating to the south over time, from time 1 being aligned like this. Time 2, you have a rift zone connector creating a small bend to connect to the rift zone. And time 3, where we are now, the East Rift Zone connector bending all the way down to the area of Mauna Loa before it heads further east-northeast towards Pu'u'o and lower.
Oh, are you with us? Oh, we might have lost him there.
It has that bend. It's the migration through time. Am I still here?
Cut out there pretty hard. Yeah, no.
Repeat that last bit here.
Probably the last like 10 seconds. I do think if you maybe can kill your cam, it might help save the latency. Just in the yard, if you can.
So just to review, this East Rift Zone connector here is lined up in the earlier time, and then develops this bend over time here to time 2 and time 3. Right? And so what I was pointing out was over here to the southwest, we see that same bent pattern here and there as well. And so that's likely where that comes from and why we see the pattern on the earthquakes here at the surface. So there is a couple other things I wanted to mention with the earthquakes. We talked about this a little bit last week, how the southwest rift zone is offset down here from the volcanic southwest rift zone. They have different depths aside. And this is all within Kilauea's upper magma system. So I thought we would do just a little bit of bonus stuff for you guys today, since a lot of other information is pretty similar, just a little bit extra here. There is illustration that came out from the Kilauea Magma Dynamics page from the Volcano Listening Project here. So here's a web page for the Listening Project, and I thought I'd pull this out. We'll go into this in more detail in some future episode. But just to point out some of the different views, big scale of that hotspot mantle plume impacting the tectonic plate of the Pacific, the hotspot island chain here, zooming into that area of interaction at hotspot and lithosphere, that hard part of the Earth, that's the crust and upper mantle. I thought this was a pretty good illustration here. You're seeing how you have multiple of these little diapirs coming up from that level, and sometimes they can reach all the way to the surface, cause some isolated eruption here or there. But otherwise, a lot of it's feeding through this larger system here. That's the hotspot route that feeds pathways to Kilauea and up through translation to Mauna Loa as well. And that's shown on this diagram to Loihi would be towards the viewer screen right here. So you can see some interesting aspects here we've talked about before. This is that base of the crust right there. See how it's bent down through that loading. The weight of the islands deforms it, pushes it downwards there. And that allows that zone of weakness, and it creates interesting earthquakes as well. And through that, the magma is coming up and through, collects likely at the base of that intersection there underneath Kilauea and Mauna Loa. It may have some lateral movement along that layer before coming up Mauna Loa. And Kilauea does a similar thing, but it's actually north-south in and out of the view of the camera here. It's a little bit harder to see. So they then zoom in even further. And here we have Halemaʻumaʻu crater at the summit with a large caldera. The pathway of magma that was present prior to 2018 fed from the shallow Halemaʻumaʻu chamber, which, as a trace to the east towards Kilauea, is underlain by a larger south caldera chamber over here, which also has a connection to this rift zone. And so this is one of these big question marks. How connected is the shallow reservoir to the east rift zone compared to the end? We've seen it in both of those have actually been activated in the past here. And not only that, they connect all the way from east to the eruption sites and beyond to the lower east rift zone. And zooming even further to that summit, and this is where there are sound programs, and we'll touch on later episodes. Within that uppermost conduit reaching towards the summit, the fluid of lava rising and flowing within that narrow pit created a whole infrasound array that was detected by the instruments and made into all kinds of audio products, which we'll talk about sometime. So today the idea is to show you different scales and different views of this concept of the magma system in Kilauea there, compared it back to what we see here, right? Very different level of detail there, but similar patterns and concepts portrayed in both. The reason I want to do this is to get at a question. This is a special bonus question, came from Pat on Discord of Two Pineapples Ohana, was asking about the pattern of earthquakes I see, right? And in particular, the question was, why are there less earthquakes between 10 and 20 kilometers depth? So I'll get to that question eventually, but I'll start off with this image of earthquake from this website here, showing earthquakes between 1970 and 2006 of magnitude greater than 2.6. And they have them split into two different depths, 0 to 22 kilometers and 2 to 55 kilometers depth. And so what you see, this one on the left is showing the magma system and the south flank of Kilauea and Mauna Loa volcanoes. If I can zoom it in here, there's Kilauea summit, there's southeast zone, south flank there, and it's a south flank as well here. Southwest rift zone, and it's a bit of south flank as well. You see similar pattern on Mauna Loa. There's Mauna summit, south flank action all through as well. We see a lot of piggybacks on Kilauea, how the volcanoes can really affect each other just by how close they are and how much the ground is moving by. If we go to that lower depth, though, you can see that earthquakes are missing in many, many places, except right around these cores of the volcano all through there. And in fact, what's interesting is there's a big gap of earthquakes, a big hole right through here, which is very near to this star, which happens to be the gravitational center of the island. And so why am I talking about the gravitational center? Because it turns out that as the island is pushing down west, it's creating lots of these flexure earthquakes we've discussed in the past, settling earthquakes, I like to call them. But it does play out that the distribution of these earthquakes with depth, there is this gap kind of between, I'll call it more like 15 kilometers, maybe 5 kilometers down. It's not like we don't have any earthquakes through there at all, but there's certainly an area where you have a lot fewer earthquakes. And so this is proposed to be the neutral plane, right? So the whole island is being deformed downwards. And what happens is, let me advance to a different image right here. We haven't shown before, but we likely will again. This is a view looking at cross section to the depth under Mauna Loa and Kilauea here. And once again, the neutral plane is shown on here at that depth of about 20 to 22 kilometers by this black line here and here. And a way to explain this, the reason I want to show this image is by its arrows that are on here. So as the volcano is piling up higher and higher above sea level, it wants to slump off and set up by gravity to the sides. So the upper part of the volcano is moving outwards relative to the center right through there, right? Below this neutral plane, the base of the volcano is deformed downwards. So the pressure makes these areas want to move towards the center of the volcano. So the neutral plane is an area of balance between it getting pushed towards the center at depth and pulled away from the center in the shallow regions. And right through there, that is a likely reason that you have this seismic window right through here, right around a neutral plane, right? You see it's a little bit larger than, in fact, there are some exceptions where you see Kilauea there and there as well. And it turns out that through some of the modeling done, interactions of this deforming, bending down plate with the magma punching through it, the magma punching through it kind of makes it weaker right there. As it blows down, that area that cracks further and further and further. So it's a combination of bending down and a magma coming through it that's creating these flare zones at the base of the crest of volcanoes there. A little bit further insight into the pattern of earthquakes here on Hawaii Island. And as we see earthquakes come from depth, we'll see this chart once again and use it to explain what's happening. And this is from this paper by Fred Klein from SGS National Park, published in 2016, lithospheric fracture under the Hawaiian volcanic load. That's all the detail from that. For those who would like to dig into it in further depth there. So we'll transition now to Mauna Loa. Just show you guys what's happening on that volcano. It's not a whole lot. We have the tiltmeter continuing its neural climb, Mauna Loa, and volcano influence with Magma. We are not seeing levels of earthquakes we saw before. Our maximum earthquakes per day over the last year still stands at 8. That's very few. We have to zoom out to the last year to get the proper context. How few earthquakes we have now compared to 1 year ago in the build-up to the 2022 eruption. Really, over the past 5 years, you can see the level of earthquake over the last 5 years on Loa as well. So this is expected. The volcano is reeling quietly without earthquakes, still refilling following its 2022 eruption. And last month, here are those deep earthquakes once in purple and blue. They're in there and there. And hopefully that makes more sense now why you have these down at the base of Mauna Loa. It's likely that weakening of the magma conduit, magma is flowing through it, pushing through it, moving things around, earthquakes happen they're not just because of magma, but because the whole mountains getting pushed down on that crust below as well. So that's our Mauna Loa update. We only have a few final community items to cover today. So we'll go to our community corner here. And before we come to some discussion of questions and perhaps repeating things that maybe I cut out while I was talking about here. So in our community list here, we have still for another week the Kilauea eruption recovery feedback for the EA for the road down in Puna. This is open for September 5th. And here's information on screen or on a Kilauea eruption recovery page. Ready to go submit comment to haven't last year. So that's our first item. There are events at the National Park in September as well, including our After Dark Park series. However, none that focus on the geology of our island volcanoes. And we'll just mention they have events on invasive wildlife on September 12th. And they have as well Search for Exoplanets on September 19th to program in the National Park, but won't cover them further unless they relate to the volcano here. Finally, we still have our Big Island Press Club internship open for Hawaii Tracker, HRA. Big Island Press Club is helping us out with this internship for Hilo students. It's probably getting to the end of the application window here for this term, I would imagine, but I have to check back for the official word on that. Still, jump in there if you'd like to get some experience in social media content and journalism this new era, right, including some of the AI safeguards we're putting in place here. And one last thing, last week put out a survey on the impact of our vocational education program. So if you have that chance, we have 140 responses so far, which is awesome. We'd like a few more if possible. Thank you guys. Only funds. But if you haven't filled out, please for the link in the chat or descriptions, and we will appreciate it as well. Right. It helps us get our funding because we reached out for our grant funders and justify the work we're doing, show that we actually have. So, yeah, Dane.
Yeah, thanks everybody for that got to this point in this stream. Thank you for our sign language interpreters. This was probably hard mode on any interpretation you ever did. It's like we had an auto-tune feature enabled. I'm to assure you that was not the case, but I did feel like dropping a beat at a few points in that whole thing. Yeah, next week, you know, this issue, it came up for just right before we went live a couple hours, and it didn't get really bad until a few minutes before we went live. And yeah, so we apologize for that. I just want to repeat, we do have the internship that is for Hilo students in journalism, social media, and then a little bit of the new age stuff we're doing on Hawaii Tracker. We also like to thank just our viewers that tuned in, but also we had a few donations that came through, so I want to acknowledge them. Really appreciate that. Let me pull up those real quick. Scott Ed came through with $20, says Carrie and Dano, great that you could offer your services. Signers are awesome. A bit to say thank you. Appreciate that, Ed. Tim says mahalo for $50 on the super chat, and also with a super chat of $50 is Dawn Stringer. No comment on that one. So we'd like to acknowledge them. Also want to point out the hvery.org website for any information about us, about the projects that we're working on, and things along those lines. Also want to thank Lou from Two Pineapples, who's behind the scenes, also experiencing the same issue that Phil is having with the internet. So it's a shared experience going on there. Thanks again, Carrie and Dano. Appreciate you guys for showing up today and, you know, giving us a test and, you know, us trying to get through this whole thing. Just to review about where we are in the volcano, because we did have a bit of a cut. So we're at the point now where the seismic southwest rift, the seismic activity is focused there. We have inflation. It's pretty much primed, but there's only 2 eruptions in that seismic southwest rift in modern history, so it's not the frequent spot that it likes to go to, but it can essentially.
Really just only one eruption. Is there more in a
Only
caldera?
only one really. Right.
Yeah.
Right. So yeah, if it's, as always, if it goes off, and in the next between now and next Thursday, which is our standard time at 5 p.m. Hawaii Standard Time, if it goes off, we get an eruption. We'll try and go live. Lou will probably be up there with the Two Pineapples YouTube, setting up the live shots and doing a long haul live stream of those opening hours. And really, those opening hours are the most impressive. And one thing about that if it does go down there, right, in that seismic southwest, the views are not going to be nearly as good if it stays in the caldera. So really, if you like looking at the lava, you're probably going to you'd be rooting for the caldera, just because people have angles to be able to shoot, and they're relatively close to the thing, as opposed to if it went down the hill a little bit.
Right, but the last 2 times this area has fell off, it's still erupted at Halemaʻumaʻu, so that's the
right. All right, very good. I didn't. What was that?
Well, I was just going to say, yeah, thanks for everyone for bearing with us here. We are always trying to improve. We're really appreciative. I just want to say my mahalo as well to Carrie and Anno, and hopefully we can do this more frequently and keep it going here. Oh, I think I froze.
Yeah, a little bit. Yep, persistent issue.
We do have big plans to get our own backup internet at some point. So when this thing happens, we'll overcome it. We're not there yet. We're getting the funding to do that. We hope in the next maybe 6 months. And that we appreciate your service. You get all a lot of you guys were really impressed and honored. And yes, mahalo once again.
Awesome. Well, thanks everybody for joining. I think that does it for me. I'll sign off for Two Pineapples. Lou over there behind the scenes helping us out. Appreciate our sign language interpreters. And that'll do it for me, Phil.
All right. From Hawaii Tracker, Hawaiian Volcano Education and Resilience Institute, we have Carrie and Dano, Dave Hunt, and Philip Ong. Hello, everybody.